In the last lecture, previous lecture, we discussed about real mode addressing and the process of segmentation. And we also stated why segmentation is necessary and how it is done in case of 8086 and what is the need for segmentation. As segmentation was needed in 16-bit architecture system, but flat model was used in case of 32. In today's lecture, we are going to discuss about. I gave a brief introduction about today's lecture in the previous lecture. Today, we are going to discuss about the addressing modes of 8086 or 8086 processor. These are just common addressing modes. So we need to take a look at them. First of all, why do we need addressing modes? As we discussed, the addressing modes describes how an instruction can find the location of its operand. So a register set, whether there is data in register set or instruction bits or I-string constants, they all are they all are used to calculate a particular address. And to calculate the process of effective address, this effective address which is mapped to some memory location. This effective address calculation we have done in the last lecture how it is done. We have a 16-bit offset, then we have a segment of 16-bit, and they all are added together, shifted left, and then we generate an effective address. And this effective address is mapped to the memory, in which the ways in which this effective address is being mapped to the memory are, we can say, they are the addressing modes. So, as we have studied two architectures, one is 32-bit, other one was 8086, which was 16-bit. So, in case of 8086, we need 16-bit of addresses, whereas in case of IA32, we need 32-bit address. So, there is a difference between the addressing methods of address generation of these two. So, memory addressing modes can be represented as we have direct and indirect, two methods. Direct addressing is simply we put an address. Indirect addressing can be classified as we have a register indirect addressing in which the address of some register is placed. Then we have a based addressing. This based addressing has the base register with some displacement. And what is this displacement? This displacement is some value, a constant value, which we will see how it is placed in the mode of addressing. Then we have indexed address. Why this is called an index address? Because we are adding this constant to define some address location. We are adding this constant to the index registers. The two index registers are source index and destination index registers. Then we have a combination of both the two based index register, based and index register. So this is a based index with no displacement. If there is no displacement added in the addressing method, then without displacement and with displacement. These were the parts of the modes of memory addressing in a 16-bit system and how a 16-bit address is generated. Let us see the difference between a 16-bit and a 32-bit address. So in Pentium, we have addressing modes. The addressing modes are, one is register addressing, one is immediate and memory addressing. So register addressing, we will study how register addressing and immediate addressing is done. But for the memory, again, we can represent it as classify it into two categories. One is direct and one is indirect. Direct is the one in which we directly place a value of the memory location or an address in the memory location. And other one is indirect. So register indirect can be categorized into register base, then base plus displacement. Similarly, as just we have categorized in 16-bit also. The same will go in 32-bit, but there is a difference. There is a difference in indexed addressing. We add a factor of scale. And what is this scale and why and how it is added in the addressing, we will see in the next slides. So index plus scale, then the combination base index with a scale factor, without a scale factor, with displacement. But in this case, there is no option of with the displacement. We have both. In both the cases of based index, we have displacement, but there is introduction of the scale factor, which needs to be taken care of in 32-bit addressing. So let us switch over to 32-bit addressing mode. These addressing modes uses 32-bit registers. In this register sector, we have, as we can see, that in this register set, one portion represents segment, a base, and index, and that's the scaling. So there is a scaling factor. If the scaling factor is added as 1, it represents no displacement. If we do not, if we haven't provided any kind of displacement, so scaling factor will be 0. If scaling factor is 2, then we have 8-bit of displacement. Or we can see that when 8-bit of displacement is provided, the scaling factor will be 2. There is no 16-bit scaling factor in this case. Only if no displacement, either it can be 8-bit displacement or it can be a 32-bit displacement. These are segment registers. Segment registers obviously are added to some offset, that is a base register or index register, any of them. So, and then we have index into a scaling factor and displacement. So this is how a 32-bit address is generated in the 32-bit processor. Let us see what is the difference between a 32-bit and 62-bit addressing. We have base registers. In case of 16 bits, these are the base registers. In case of 32-bit addressing, these are base registers. Then we have index registers, SI and DI. There, these all can be used as indexed registers. Now we have a scaling factor. There is no need of a scaling factor in case of 16-bit addressing, and hence none of the scaling factors are present in this case. But in case of 32-bit addressing, we need scaling factors, and we have 1, 2, 4, and 8 depending upon the type of bit addressing. So displacement in case of 16-bit addressing can be 0, 8, or 16, whereas the displacement in case of 32-bit addressing can be 0, 8, and 32. There is no 16-bit of addressing because 16-bit addressing is already present in this kind of process. So let us discuss the addressing modes of 8086 one by one. As we all are familiar with the addressing of 8085 microprocessor, it is just an extension or some more addressing modes that have been added to this architecture. Let us discuss register mode of addressing. As you all are familiar, both the operands are registered. When data is moved from one register to another register, it can be represented by this instruction. These two operations represent the register mode of addressing. If it is an immediate mode, the source operand is a data. In this case, at 8086 16-bit processor, the data will be 16-bit data. So if I represent that data in facts, it will be a 4-bit representation. And these are the examples of immediate mode of addressing. Then the next is displacement or direct mode. So direct mode of addressing, you all are familiar with it. But the direct mode of addressing is also known as displacement. Actually, direct mode is displacement as we are providing a value. Actually, the effective address is directly given in the instruction as displacement. This is effective address, and this effective address is this value is represented by is known as some displacement. So this is the direct mode of addressing. Then register indirect mode. Effective register is in source index or a destination index or DX. So this represents some address in this register set, and that address is pointing towards some address in the memory position. So register indirect mode, instead of providing the data directly, it provides some location or address in the memory, and hence this is known as register indirect addressing. Next one is indexed mode. In this case, sum of index means having index register to represent the address, plus we have added some constant value, that is displacement, to this part. So this kind of or this mode of addressing is regarded as indexed mode. So next if we switch over to, this is the based indexed mode. The effective address is sum of base register and index register. So base register and index, these are known as base register, index register. The physical memory address is calculated according to the base register. So if we add base plus index, this becomes the base index mode of addressing, and then the primary. There is one more relative, more mode of addressing, which is known as relative mode of addressing. As this effective address is calculated with reference to the instruction pointer. Suppose we are executing a sequence and the particular instruction jump if not jump if 0. So jump if not 0. If a jump if not 0 plus an address location has been provided which is 8 bits away from that part. So this will switch over to that one. Or the instruction pointer in this case, IP is equal to IP plus 8-bit address. Whatever be the 8-bit address we have, this instruction pointer will be updated by that 8-bit address. So this is just an updation method. Then we have based mode. Effective address is sum of base register and displacement. If displacement is added to the base register and then we address a particular location, then this is based mode, based index, displacement mode. In this case, all the three parts, index register, base register, and displacement, they all the three parts are used to address a particular location. So these were the addressing modes of 8086. If you want to refer more examples, you can go through. I suggest you to go through microprocessors and interfacing by Douglas V. Hall. So this was a part of addressing modes of 8086. Let us switch over to the last topic of this module, which has been mentioned in the curriculum. That is the instruction set. But before going to, there are two more. Sorry, I skipped them. Was skipped accidentally. So we have two more modes to discuss to tell you about. One is a string mode and one is a IO mode. They are just this is for input-output operation when a particular address or particular register set is accumulator is located, as the accumulator can perform IO operations. So accumulator is addressed to a particular port or location. So this is the addressing mode of IO. A string, when a string SI and DI are auto incremented or decremented depending upon the value of directional. So this is known as string mode of addressing. You can see this. So let us discuss about the instruction set of 8086. As there are many more instructions to be followed, but 8086 has basically 117 basic instructions. They have 117 basic instructions. There are 100 and something basic instructions in 8086 processor. And they have been extended certainly in the higher versions with a more advanced features added to the processor. So the instruction set of 8086 can be classified basically into 8 types. The instruction sets are of 8 types. They are as such. One is data transfer instruction, then we have arithmetic instructions. We have bit manipulation instructions, string instructions, program execution transfer instruction, which involves branch and loop execution instruction. So then we have process control instructions, iteration control instructions, and interrupt instructions. So let us discuss them one by one. First of all, we have data transfer instruction. So data transfer, as we all are familiar with data, the instructions which are used to transfer data from source to destination, one part to other, and there are various modes of addressing to transfer data, to fetch an instruct, to fetch some data or to execute some code. So data transfer instructions are made in use. On its data transfer instructions, as we can see, we have some of them are very familiar to you. We have move. This is not p push. This is push only. Maybe mistakenly written here. So then we have push, pop, which are the part of instructions which are part of used for stack popularly. Then we have push A, pop A, exchange, which was also which you might have seen in 8085 microprocessor also. Then we have XLAT, XLAT. This is used to translate a byte in AL using the table economy. Then the instructions, these are just the parts of data transfer instructions. These are common instructions, and now let us be more specific in data transfer instructions. One is instruction for input and output port transfer. So input and output port transfer we are using. So in and out, we have seen one of the examples in the last addressing mode of IO mode. We used the instruction in and out. If you remember, that we used this instruction in A, out A. So this IO mode of addressing will represent it for input and output port transfer instruction. Then if we need to transfer the address, instruction to transfer the address, then these instructions are part of instruction transfer address. To transfer flag registers, the instructions are shown below. Then the other type of instructions are arithmetic instruction, addition, perform addition, subtraction, then multiplication, which are the addressing mode, arithmetic operations of the processor, division. So then after arithmetic instructions, we have bit manipulation instruction. I need not to read every instruction. You can go through this presentation later on to know what is the function of a particular instruction. I'm just giving an overview of these instruction sets that should be followed. So we have bit manipulation instruction. So instructions to perform part of bit manipulation instructions. What will be bit manipulation instructions? So bit manipulation instructions are used to perform operations where data bits are involved. That is, examples are we have a logical operation, shift operation, then we have rotate operations. These operations are just required to manipulate the bit. So you can go through them. These are written and their particular usage are also written in them. The instruction to perform logical operation, we have 4 logical operations, and more can be added to the subsequent versions of the processor. One more thing is then we have shift operations, shift left, shift right. We are also familiar from 8085 microprocessors to shift data stream to left or right. Then to perform rotate operation, this is also, we have seen a lower version of this rotate operation. There are some more features added to this 8086, and as it is a 16-bit, so rotate will take some more time. So larger bit, larger stream is involved. It has to be taken care of. So we are dealing with a byte or word towards right. So used to rotate bits of byte or word towards right. Used to rotate bits of byte or words towards left. What is happening? Carry flag. So these you can see their implementation is also important, but in your curriculum, using the instruction set is has been mentioned. So I'm just giving an overview of this instruction set. You can go through them in detail. You must refer to the book to study the implementation and detailed description of these instruction sets, to study the T states, how many T states, what is the machine cycle, uh, and what is if the instruction is of 2 bytes, 3 bytes, or a single byte instruction. You have to go through the detailed instruction set of this 8086 architecture. I will share a document with all of you in your groups, so you can go through that document if you want to study in detail the instruction set of this processor. The next we have string instructions. So these are string instructions to repeat a particular sequence, and these are the instructions representing the strings. So strings are set of words or bits. A string is a group of bytes and words, and their memory is always allocated in a sequential order. So a string instruction has to be followed, or has to follow a sequential order. But it is handling a group of bytes and words. So this involves the following instructions. You can go through them in the subsequent in your slides. Then we have the next kind of instructions are program execution transfer instruction, which are also part of branch or loop instruction. A conditional statement, we are talking about conditions. But there are some instructions which have to be executed. Instruction to transfer the instruction during an execution without any condition, which are not, which are beyond conditions. They do not follow any conditions. So, what are the instructions? They are very specific. There are only 3 instructions. One is the call instruction, used to call a procedure and see if they return address to the stack. Then we have return, used to return from the procedure to the main program after running service routine, as you all know. So then we have a jump instruction. So jump instruction to, if for a particular condition we have to jump to some address location in that particular program, or to execute some other instruction or some other set of instruction or some subroutine. So these are programs which are unconditional, but there are some instructions which are conditional. So instruction to transfer instructions to transfer the instruction. See what we are saying, that instructions to transfer the instruction during an execution with some condition. Now this is conditional transfer of instructions. So for the case of conditional transfer of instructions, we have a more instruction, expanded instruction set to be followed. As we can see, there are much of the instructions in this set, or in this part of set. Used to jump if greater than, not less than, equal instruction satisfied. There are various conditions. Jump if not 0, jump if 0, jump if carry, jump if not carry. So depending upon the flag register, we had instruction sets in 8085, as we had only there was 8-bit of flag register, and the 5 of them were active. But in this case of 8086 microprocessor, we have a 16-bit flag register, and there are much more flags or status to be updated. So these instruction sets generally represent the status of the various flags, and depending upon the status of the various flags, these instructions has been modified in 8086. So apart from all these instructions, then program execution transfer instructions, which are used to transfer branch the instruction during an execution. We have one more type of instruction set, which is known as a processor control instruction. So processor control instructions, these instructions are used. So these instructions are used to control the processor action. These instructions are used to control the processor action by setting and resetting the flag. So again, there is a bigger role to play by the flags. The flags are also controlling the process of the microprocessor. So process control is also being done by flag registers. Program execution, transfer, branching, and loop is also being done by the status of the flag register. So as I have mentioned earlier, the flags are status manipulation. There is a flags involve status manipulation. If we are not transferring data, maybe we are not manipulating the data. If we are not changing data, maybe we are not manipulating data. So, but we are changing the status of the flags. So that part is known as the status manipulation. And by changing the status of the flag, we are changing much more in our process. As we can see that two instruction sets, program execution transfer instruction set, and then process control instruction set, they broadly use flag register to represent the status. So these are the processor control instructions. These are used to carry flag here. So these are instructions that you can see in the diagrams. Then apart from these flag registers, there is one more category of instruction sets. As I have already told you, we are just discussing the basic instructions of this processor. So do not get confused that these are the only instruction sets. I'm just giving an overview of this instruction set, as this is a very broad section of the processor, and you can go through them or share a document. You can go through them in detail about the instruction sets of the processor, microprocessor. So we have iteration control instructions. If for the case of iteration control instruction, these instructions are used to execute the instruction for a number of times. So these are used to execute the instruction for a number of times. As we are familiar with the concept of iteration. Iteration is something that if we are executing a single instruction for the number of times, say for loop, while loop, they are executing loops. They are iteration control. How iteration control is done? This will be controlled by these instruction sets. So loop, loop E, loop set. What is the use? You can see in the manual. Then we have this instruction. Then we have JC, XZ. There are certain instructions to control the iteration. And after this instruction set, the last part in this instruction category is interrupt instruction. So interrupt instructions are used to handle the interrupts during the program execution. So interrupt instructions are INT, INTO, IRET, return, returning from the service routine to the main program. Then we have IRET, interrupt service to the main. INT used to interrupt the program during execution. If a flag is set, overflow flag is set. Then we have used to interrupt the program during execution is called and calling service specifier use IN. So depending upon the types of instruction and how a processor deals with the instruction, these interrupt instructions are provided. So you can visit these instructions and the instruction set manual that I will share with you at the end of this lecture. And now we can say that modes of addressing, more practice is needed in case of having a deep understanding of the instruction set and addressing. And you have to go through, maybe you have to go through the programming part somewhat, a little bit of programming part of this process. So this was the part of last part of your module number 4. This completes the addressing modes of 8086, and the instruction set of 8086. As this is to be emphasized again and again, you must go through the manual, you must study some things, these instruction types in detail. Uh, as it has been mentioned in your syllabus, this is just an overview of the instruction set. I have time constraint as we cannot discuss every instruction in detail, whether it's a key state or uh, machine cycle. So you need to go through them. So this is all for today, and this completes the curriculum of module number 4. From the next lecture onwards, we will start with module number 5, that is instruction level parallelism, concepts of pipelining, branch control, branch prediction, etc., and branch cost. So go through these lectures. I will share these lectures with you. Then you can go through them. If you have any queries, we can resolve them on Google Classroom, or even Google Classroom. This is all for today. And, thank you very much.